The first screen shows the process as actually executed. The dark blue boxes show the activities that are executed the most frequently, and the dark arrows show the path of the process that is taken the most frequently. On the right, we can see which process variants are taken most frequently. This might indicate areas where automation is likely to pay benefits, but more investigation is needed. We have preloaded a reference process created with BlueWorks Live that says how the managers think the process should be executed. By comparing this reference process to the actual data, we can see in red the process activities and tasks that are not compliant with the reference process. This could indicate where there are errors and unexpected delays, more candidates for automation and process improvement through orchestration. The duration view shows which activities are actually taking the longest on the average. The dark orange indicates the longest steps in the process. Again, this can indicate where we want to investigate automation to speed up these delays, if they are due to automatable steps rather than, for instance, outside delays. Service closure looks like a suspiciously long step here, taking 52 hours. We did task mining in this area, and we can drill down into the task mining view to see the detailed steps that humans take to execute this process. These steps can be mapped into an RPA bot. Once again, we can see the frequent steps and the long duration steps and look at the different process variants. If we do an RPA bot, we will probably want to start with a bot that automates the most common variants of this step. Once again, we see that service closure is an automation candidate due to the total time spent here. By looking at the analytics view, we can get a fuller picture of how people spent their analyzed time on their desktops in the different steps. We can see how much time they spent actually executing the task, how much time they spent idle, and how much time doing other things. We can see here that people spent 1 hour and 4 minutes doing real work, and the rest of the time was spent doing something else. So maybe an RPA bot here would not save as much as we might hope. Going back to the duration view, we see another activity, pending request for network information, that is also introducing delays as well as pending liquidation request. Here we do a drill down into the pending liquidation request activity. Now back in the overall process view, we want to ask the tool for automation recommendations, and to do that we go in the dashboard view. For each possible activity, we get some statistics about how automatable it is. In the RPA Candidates tab, we get the process mining tool to recommend bot priorities using this data. We can see which activities might turn into bots and the expected cost savings from that automation. We can set thresholds for target activity automation level. In other words, how many instances we replace with bots. And max RPA complexity. In other words, how many different process variants we consider putting into a single bot. More variants make more complex bots. If we have set the thresholds, we can simulate the overall impact on the business process if we were to implement and deploy the suggested bots based on the time reduction for those process steps done by some bots replacing some humans. Focusing on the back-office service closing activity, we are simulating the impact of having 57% of the process instances done by the bot rather than the human. Now we run the simulation and we can see the comparison of the simulation with historical data. The BO service closure activity time has been cut a lot thanks to the bot. We can see that the new automated scenario with several bots reduces the overall average execution time from 18 days to 12 days, a 33% savings in time on the average. In this case, the average cost per case has not decreased because we are still employing the same number of people overall, but they are getting the work done much faster.